oh, doing that wrong. Okay, so today we're going to work on solving rational equations. So we were just simplifying expressions on Friday. Today we're actually going to solve them. So I love rational equations. I think that they're kind of like a fun puzzle to do. The students who have trouble with these don't know how to do fractions correctly. So that could come back to get us here if you have some trouble with that. Rational equations. A rational equation is any equation that has a variable in the denominator of a fraction. It may also have variables in the numerator, but it must have variables in the denominator. And it might only be one fraction that has a variable in the denominator. But if there is a variable in the denominator anywhere, then it's considered a rational equation. Oh. Okay, so just to review, we went over this the other day, but just to review, if you need to add or subtract fractions, you're going to get a like denominator, add the numerators, keep the denominators the same. Okay, so if we're going to add, we must have common denominators. If we're going to multiply fractions, we do not have to do that. We just multiply the numerators, multiply the denominators. Okay, so that'll be important for us. So let's look at our first equations that we're going to solve. Dividing's different because dividing's going to be dividing fractions, easy as pie, flip the second, multiply. So basically all division we just turn into a multiplication problem. So I've got for this first equation, c minus 4 divided by c is going to equal 3. So if I'm trying to solve this, usually when we're trying to solve an equation, we try to get all of our c's together, and then we add or subtract, multiply or divide to undo what was done. But I'm not going to be able to get these c's together when one of them, this isn't written like a fraction, but it is like, we could put it over one like it's a fraction. One of them is in a numerator, and the other is in a denominator. Okay, so what we want to do for these problems is we want to give everything a common denominator. Okay, so we want to get common denominators for both sides, for every term of the equation. So if you have anything that is not a fraction, you want to put it over 1 to make it a fraction. And then this one's pretty simple on the denominator. C is my denominator right here, so I just need to turn all of the denominators to be C. To do that, what I'm going to do is I'm going to multiply the numerator and the denominator of each term by C. I can do that because if I multiply the top of a fraction by something and the bottom of a fraction by something, then it's like multiplying by 1. If I had 1/2 and I multiplied it by 3 over 3, that would be 3 over 6, which still equals 1/2, right? So we can multiply a fraction by the top, we can multiply the fraction by anything as long as we multiply that same thing in the top and the bottom. So when I do this, what is c times c? It is c squared. Good. So I get c squared over c minus 4 over c equals 3c over c. And if I wanted to, over here on this left-hand side, I could write these together. C squared minus 4 all over c equals 3c over c. So now, it really looks no better than it did to begin with. Now I've got a square, it looks worse. But I've got these denominators right here. That c is in the denominator on both sides. So if I multiply both sides of the equation by c, and that's like multiplying by c over 1, this is okay to do because I did it to both sides of the equation. So if I multiply both sides by c, now I've got a c in the numerator and a c in the denominator on both sides, and my denominators are just going to cancel out for me. So I've got c squared minus 4 equals 3c. And this is going to be what happens with all of your problems. You're going to get common denominators, then the denominators are going to cancel out so you don't have denominators anymore, and then you'll solve what's left. Now, I will tell you that more students have trouble solving from this point than they do from the beginning once we go over this. So here you should either be getting a quadratic or just a regular equation you would solve, like if you're in Math 1, just a simple linear equation. So if I get a quadratic, I need to move everything to one side. So I'm going to have c squared minus 3c minus 4 equals 0. And then for a lot of these, they are going to factor. For some of them, you might have to do quadratic formula or complete in the square. But this one, I could do c minus 4 and c plus 1. So that will work. So I will get c equals 4 and c equals negative 1. Oh, I forgot to do something. Now, one thing we do have to be really careful of here is excluded values. So, whenever we were taking those notes on Friday, we talked about the excluded values. And the excluded values were just anything that made your denominator 0. So if I go back up here to the original problem, my excluded values were just x cannot equal 0. Right? Because I could not have c being 0 because that'd give me 4 over 0, which would be undefined. So x cannot equal 0. So we really want to check for that at the beginning of every problem, because if I had gotten 0 as an answer, I would have to throw that answer out. It has not happened that often, but it does happen. Like, I know that on some of the quiz and test questions that I got here, it happens occasionally. Not often, but occasionally. So in this case, I got the answer 4 and negative 1, which are both fine because they don't equal 0. Okay, questions? All right, so let's look for excluded values at the beginning here, because I really should do that every time. So excluded values here, I'm thinking of anything that will make my denominators 0. What would make my denominator 0 here? It's 0. Even with that 2 and the 3, it's still just 0 that would make those 0. If you need to, if it's not super easy to figure that out, you could just say 2n cannot equal 0, 3n cannot equal 0, n cannot equal 0. Just set all your denominators not equal to 0. Okay. So if I get 0 as an answer, it can't be my answer, and I have to throw it out, which does happen occasionally, but probably not that often. So you at least need to think about that at the beginning of the problem, even if you don't write it down. All right, so I've got 2n, 3n, and n. What could I use as my common denominator here? Matthew? 6n. Good. So if I need to get a 6n, what do I need to multiply this first equation, or first fraction by? 3. Make sure you're multiplying on top and bottom. The second fraction needs to be multiplied by 2. Make sure you put some parentheses around whatever's in that numerator there, because you're going to have to multiply the whole thing by 2. And then the last one, 6. So this is going to give me 3 plus 2 times 6n minus 9 equals 12, and this is all over 6n This is all over 6n. Or you can write the 6n separate on that left-hand side. It doesn't matter. So, you'll start to notice here, this happens every time. Once you have those common denominators, if I multiply by 6n on this side, and I multiply by 6n on this side, it's like 6n over 1 here, 1 in top and bottom. It just cancels the 6n's. Eventually, we're just going to kind of start shortcutting that and mark it out from the beginning anyway. So, I'm left with 3 plus 2 times 6n minus 9 equals 12. Okay, questions so far?
How do you get 6n over 1?
So what I'm doing is I'm just multiplying both sides by 6n. So, like, if I was solving an equation and I had, like, x over 4 equals 12, I could multiply this side by 4 and this side by 4 to solve it, right? And so I cancel these 4's over here, I get 48. So it's okay to multiply both sides of an equation by anything. So what we want to do is we want to multiply both sides of the equation by that common denominator, and it will cancel on both sides, and then you'll just be left with an equation. It's fine if you do. I just held off because sometimes if you distribute, you might mess it up. It really happens when we mess it up a lot if that's a minus sign right there because the negative's got to be distributed with it. But if you did, that's fine. You could. It'd be like a -2 that you were distributing there. So if we distribute, we will get 3 plus 12n minus 18 equals 12. This is just a regular equation. Just Math 1 solving equations, right? I could give this to my Math 1 class and maybe 60% of them could do it correctly for me, right? So I got 12n, I'm going to put the 3 and the -18 together, which is going to give me -15 equals 12. I will add 15 to both sides. So 12n equals 27. And then I will divide by 12. 12 will not go into 27. It will reduce. You could divide both of those by 3. So you would get 9 over 4. And 9 over 4 does not equal 0. It's not an excluded value, so that is our answer. Correct. Right. It mostly depends on whether or not, once you clear all of your fractions, if you've got a square or not. If you have an x squared, you're usually going to get 2 answers. If you do not have an x squared, it's usually just 1 answer. Yes? Right here, or what? How did we decide it was 6? So you treat it just sort of like if you were going to add 1/2 and 1/3 together, sort of ignore that n. You think about what would be the common denominator for 2 and 3. And so the common denominator there would be 6. Okay, questions? All right, let's move on. Okay, so we've got to think of a common denominator here. I've got pretty much the same numbers, right? 2, 3, and 6. What's our common denominator for 2, 3, and 6? 6. I've got x squared, so that needs to be part of my denominator as well. Okay, so my least common denominator is going to be 6x squared. Let's think excluded values really quickly before we go to solving this. Excluded values here are, again, just going to be x cannot equal 0. Because if I set all of those denominators equal to 0, I would just get 0 for those. So if we get 0 as an answer, we got to throw it out. Alright, so the first fraction here, it needs to be multiplied by 3 on top and bottom so that we will get 6x squared in the denominator. The second one, it needs to be multiplied by 2 so that we get 6x squared. What about the last one? Okay, multiply by x on top and bottom. Can I square it? Can I square top and bottom of a fraction? If I have 1/2 and I square the top and bottom, I get 1/4. That is not the same as there. So you want to multiply by an x. If you are going from like a regular x to a squared, you need to multiply by x, not squaring top and bottom, because you can't do that. So this is going to give me 3 over 6x squared equals 2 times x plus 2 over 6x squared minus.
Pardon the interruption, I do have one announcement I need to make. This is mainly for first lunch students in first lunch, especially those who have been eating on the back patio. The back patio will be closed for the rest of the week for first lunch students. We had several students left a mess out there today, several trays, several things. The least you can do, guys, is pick up your trash and put in the trash can. The back patio will be closed for first lunch for the remainder of this week. Thank you.
I don't want any of you guys. Children. Alright. So, when I get all these denominators the same, I can multiply by 6x squared, and I can put these out all over just one 6x if I want. But I'm going to multiply this side by 6x squared, which will cancel this out. I'll multiply this by 6x squared, which cancels these out. So basically, once you get your common denominators, you can just drop those denominators, is what we'll be doing every time. So we're going to have 3 equals, I'm going to go ahead and distribute this 2 now, 2x plus 4 minus x. And then 2x minus x is just x plus 4, and we will subtract that 4 there. Negative 1 equals x. Negative 1 is not an excluded value, so it is fine. Okay, questions? Alright, here's another one that's going to be a little bit different. Yes. Okay. Alright. So, my denominator right here is m minus 3. My denominator here is m plus 3. I need them to match. So initially what I think about is maybe I could just like add 6 here and add 6 here. Don't write that down. Can I do that? If I have 1/2 and I add 6 to the top and add 6 to the bottom, does it still equal 1/2? No, it equals 7/8, which is not even close to 1/2, right? So you cannot add and subtract from the bottom. It has to be multiplying or dividing. So do not try to add or subtract. It's going to be tempting to do. But I can multiply. You can, but if you multiply by a negative, like, so let's say I multiplied this one by a negative, I've got to distribute the negative to both terms. So it will give me negative m minus 3, which is not the same as the other one. And then you might think, well, multiply this one by negative. Well, if you do that, you got to distribute negative m plus 3. Still, they don't match, right? So we're not going to be able to do it with negatives, although that's a good thought. Sometimes there will be times where that will be what we want to do, but it won't work in this case. Sometimes, maybe if I had, for example, if I had negative m plus 3 instead of just m plus 3, then it might work. Alright, so, for our least common denominator, we're just going to have to use basically all the denominators multiplied together. So, m minus 3 times m plus 3. And that will look like this. Okay? So, for this first term, I don't have anything in that denominator. In fact, I had to put a 1 there just so I had a denominator at all. So, I'm going to have to multiply the denominator by m plus 3 and m minus 3. Which means I got to multiply the top by m plus 3 and m minus 3. So, it did not have either one of my least common denominators there, so I had to multiply both. But when I go to the middle fraction, it's already got an m minus 3. What do I need to add to it? M plus 3. So m plus 3. Make sure you put it in parentheses whenever you're doing this. And the last one is going to need an m minus 3. So, will it be alright with you guys? All my denominators are now the same, right? I've got, for the first fraction, m plus 3, m minus 3, m plus 3, m minus 3, m plus 3, m minus 3. Denominators are the same everywhere. So, what I'm going to do is I'm going to put them together and then I'm going to multiply and the denominators go away. So, is that alright with you guys if I just go ahead and mark them out right now? Okay? Save us a step of writing things down. So, once you get common denominators, you can mark them out. So, I am left with m plus 3, m minus 3. Right here is a really good place to make sure, don't distribute just yet, or if you do, you got to recognize that negative goes with the 2m. So, I'm just going to wait. Now the 1 here, I'm just going to make this m minus 3. Alright, so to multiply m plus 3 and m minus 3, I've got to distribute, but this is going to be a difference of squares, because I'll have m times m, which will give me m squared. And then I'll get negative 3m and positive 3m, which is going to cancel. And then 3 times negative 3 is negative 9. And I will distribute my 2m, so minus 2m squared minus 6m equals m minus 3. Okay, questions? Alright, so we're going to solve this. I'm going to combine my like terms first. So m squared and negative 2m squared is going to give me negative m squared minus 6m minus 9 equals m minus 3. And this one is a quadratic. What do I have to do when I want to solve a quadratic? Got to be equal to 0. I would suggest that you keep your m squared positive. So like whenever you subtract this m and add this 3, if you do it this way, you got negative m squared minus 7m minus 6 equals 0. It's going to be really hard to factor with a negative m squared, so I would either move everything to the other side, or you can just multiply through by negative 1 here, which just changes the sign of everything. So m squared plus 7m plus 6 equals 0. So if you find that you have a negative x squared there, just multiply 3 by a negative to get rid of that negative. Most of these will factor. You'll have a few that won't. So this one will factor. So we'll get m plus 6, m plus 1. So m equals negative 6, and m equals negative 1. Yes? I should have. I was just thinking. I should have looked for excluded values. What would the excluded values be here? It's going to be m plus 3 cannot equal 0, which gives me m cannot equal negative 3. And it's going to be m minus 3 cannot equal 0. So that's going to give me m cannot equal positive 3. Since neither one of my answers are positive 3 or negative 3, then they are the answers I'm supposed to have. So yes, that was a good catch, Wesley. I should have done that at the beginning. It's one that's really easy to forget because it doesn't actually make a difference. Like, we could have forgotten it on this one and it wouldn't change anything about our answers. But there are a few that you'll see where it matters. And I can't remember if I want to say that I forgot to put one of those in this, in our problems here, but it does happen sometimes. If you get one, like, you would just mark it out. And so, like, if we had two answers, we have negative 6 and 3, we would just mark out 3, and negative 6 would be our only answer. If you ever get one where all of the answers are excluded values, then it would be a no solution. That's even more rare than, than having one of them excluded, but it could happen. Okay, questions? All right, here's our next one. So, since I forgot last time, let's go ahead. Excluded values. What would they be here? X cannot equal negative 5, and X cannot equal 1. So, if we get negative 5 or 1, we have to throw those answers out. Alright, least common denominator. What should we use here? D plus 5, D minus 1. Just the denominators multiplied together. So, it's a good idea to put these in parentheses here. So, the first fraction, what am I missing here, Wesley? What do I need to multiply by so I have the full least common denominator? Good. And so if I multiply in the bottom, I also have to multiply in the top. Manuel, what do we need to add to the second fraction? D plus 5. So D plus 5 goes here. Make sure you're using those parentheses. And then, let's see, Raven, what about the last one? What do we need to add there? Good. D plus 5 and D minus 1. Now, my denominators should be the same for everything now. So I'm just going to cancel them out. Save me a step of writing all that. So I have 3 times D minus 1 plus 2 times D plus 5 equals 1 times D plus 5 D minus 1. Okay, so I just distribute here. 3D minus 3. Distribute here. Plus 2D plus 10. equals, here I've got to do d squared minus d plus 5d minus 5. And let's combine some like terms on each side. So we'll have 5d plus 7 equals d squared plus 4d minus 5. Now, this one is a quadratic. What do we do when we want to solve a quadratic? What? Equal to 0. So I'm going to subtract this 5d right here to move it over to the other side. And subtract that 7 to move it over to the other side. So I get 0 equals d squared minus d minus 12. And this one will factor. I'm going to have d minus 4, d plus 3. And so d equals 4 and d equals negative 3. Are either one of those my excluded values? No, that was negative 5 and 1. So these are both answers. Okay. Questions? Okay, let's look at this one. Alright, so this one looks like we're going to have to do a least common denominator of k plus 3 times k squared. Don't write this down yet, it's not right. K squared plus 5k plus 6. Right? It looks like that's what we need to do. And you could do that. But if you do, you're going to end up with a more complicated equation. In fact, I think we actually could do this here because it would be a quadratic and we could solve it. But I think there would be an excluded value. But there is an easier way. Because what does this factor as if I factor this denominator? K plus 3, k plus 2. Okay, so it factors into k plus 3, k plus 2. So I could use, instead of using this, I could just use k plus 3, k plus 2, right? And if I do that, the only thing I have to do is multiply the second equation, or the last fraction by k plus 2 on top and bottom. So if you see something that will factor, try to factor it, and there's a good chance that it's already going to have a part of that denominator in it, so that you don't have to use those big long ones. If you are solving these and you end up, like once your denominators are gone, you have something to the third power or higher, there was a smaller least common denominator that you could have used. Everything here should either be linear or quadratic. You should not have anything with x to the third power. So our k's, they can cancel out. If I give this problem on a test, half of you would miss it every time. Why do you think it is? It's not because of the denominator. What do you think somebody's going to forget to do? They'll probably remember the k plus 2, but that's a possibility. It's this minus right here. It has to go with, so what we've got here is we've got 3 minus k minus 6. And you have to distribute that negative. So it's going to be 3 minus k plus 6. Usually this test I grade by hand. I don't give it on Canvas. And sometimes on these problems, I go ahead and work out the answer to tell me what you would get if you had a -6 right there. Because there will be so many kids that get that, and then I say, oh, they've got 5/3. I take off 2 points here. I know what you did wrong just by looking at your answer, because it's so common. If you have minus signs, you've got to distribute them. Be really careful. So we're going to have 9 minus k equals k plus 2. Sorry, my program's not good. And so I could add that k. So 9 equals 2k plus 2. Subtract my 2. 7 equals 2k. And the last step is we would divide by 2. So k equals, you could do 3.5 or 7/2. It doesn't matter to me which one you get. Yes?
How would you find the excluded values?
Excluded values, use the factored form of your least common denominator. And so, we should have done this from the beginning, but x cannot equal -3, and x cannot equal -2. So don't worry about the longer part, because when you factor it, you've broken it down. And neither one of these are excluded values, or this is neither one of our excluded values. So 7/2 or 3.5 is our answer. Yes?
We just use the excluded values to check our answers.
Just to make sure that they are not an excluded value. And I think I failed to put one on in these notes where that happens.
So if the answer is an excluded value,
Then you just mark it out. Yeah, and if it's the only solution, then there'd be no solution. I think it happens at least once on this. Do you guys have this problem? Or, okay. Is this the last one? Okay, it is. Okay. All right. Okay. So, for this problem, I see this x squared minus x minus 6. I'm thinking I probably need to factor that. So, let's factor. We want to factor before we worry about the excluded values. So, I'm going to mark this out and I'm going to factor it. So, x and x, I could do a -3 or plus 2. So, if I look at my least common denominator, for your least common denominator, you're going to use all the parts, or all the denominators multiplied together, but if something's already there, you don't have to list it twice, right? So I'd have x minus 3, and I'd have this x plus 2, and a 3 minus x, but I'm not going to write that down right now because 3 minus x is really close to being x minus 3, right? It's really, I just need to switch the order of it, and it could be x minus 3. So earlier, whenever you guys were suggesting that I multiply top and bottom by a negative number, like by a negative, right? I said it wouldn't work in that situation, but we might use it somewhere else. So right here, what would happen if I multiplied this denominator by -1 and the numerator by -1? What would it do to this denominator? It's going to flip it, because you're going to have -3 plus x, and then what is that? It's x minus 3. So, if you have just the opposite of what you need, so you need x minus 3, but you've got 3 minus x. You can multiply the top and bottom of that particular fraction by a -1. And if you do that, it will flip that back around to be what you need. So I'm going to rewrite it so that we're really clear about what we're doing here. So now what I've got is I've got 2x over x minus 3 plus -5 over x minus 3 equals 9 over x minus 3 times x plus 2. It is going to make it a lot easier to do this problem if you do that. Because if you don't, then you're going to end up with something that's x to the 3rd you don't know how to solve something that's x to the third unless you remember synthetic division and P's and Q's from Math 3. And I'm not going to go back over that, so I'm not going to give you anything where you get x to the third. So if you recognize that you're getting x to the third, you could have probably flipped one of those so that they match. All right, so now we just need common denominators. Any questions before I go on to that? Okay, so we would multiply this first fraction by x plus 2, the second one by x plus 2. What do we multiply the last one by? Nope. It already has an x minus 3 and an x plus 2 in the bottom, so we multiply by nothing. We leave it alone, which is sometimes confusing. Like, sometimes students do that wrong because it seems strange to leave that alone, but we leave it alone. So, so now all of my denominators match. I'm going to simplify, so I got 2x times x plus 2. If you want to go ahead and distribute, that's fine. I just want to make sure I don't lose anything along the way, so I'm writing an extra step here. And so we would distribute, so 2x squared plus 4x minus 5x minus 10 equals 9. And so we're going to get 2x squared minus x minus 10 equals 9. We subtract that 9. 2x squared minus x minus 19 equals 0. So I've got everything to one side like I need to with a quadratic. So if I'm factoring that, I got 2x and x. And I got to get 19. What's the only things I can multiply to get 19? 19 and 1. So I can put 19 and 1 here, but that's going to give me 19 and 2. That is not going to give me what I need. If I switch where they're at, still not going to give me what I need, right? This one does not factor. So you're going to run into a few of these that do not factor. So if they do not factor, you are going to have to use quadratic formula. I'm not sure you'll run into it today on your assignment because it's on Delta Math, and I don't know. I want to say Delta Math had whole number answers for everything, or at least fractions, not quadratic formula, but I could be wrong about that. So we could use quadratic formula or completing the square. I would suggest quadratic formula on this one, because if you do complete the square, you got to divide everything by 2 first, which gives you 19 over 2 and 1/2, and you got all those fractions. So I just go quadratic formula. So negative b, so it's going to be 1 plus or minus square root b squared. So negative 1 squared. I never put, like, even though that is a negative 1, I never put a negative 1 there. Because when you square anything, what's going to happen to it? It's going to become positive, right? So if you put a negative there, you're just likely to make a mistake with it, so I just don't even write it down. So I always do, like, the absolute value of b squared minus 4 times a, which is 2, times c, which is negative 19, all over 2 times 2. So we're going to get 1 plus or minus, let's see, it's going to be 1 minus 153 all over 4. Let's see, 153, is anything go into it? I don't think so. Oh, yeah, it does. 9 and 17. Uh-oh. So, gosh, I keep doing it. So, this will break down into 9 and 17. So, 1 plus or minus 3 root 17 over 4. That will not reduce any further, so you would leave that as your answer. I forgot excluded values again, but x cannot equal 3 and x cannot equal negative 2, which is not equal to either one of those. So our answer here. All right, questions? No, it is a solution. It's 1 plus. Oh, it's 1 plus or minus 3 square root of 17 over 4. You leave it at that, yeah. If we wanted, we could get decimals for it, but I'm most of the time going to want that exact answer. All right, so your assignment is going to be on Delta Math.